Astronomers have just detected a special fast radio burst, FRB, originating from an extremely remote region of space, where the necessary physical conditions, such as a strong gravitational field and abundant energy sources, often do not exist to trigger similar events. Initial analysis indicates that this region lacks the key factors that current theories deem necessary for the formation of FG. This discovery not only raises challenging questions about the formation mechanisms of FRBs, but also opens a new chapter in the journey of cosmic exploration. When scientists are compelled to re-examine traditional hypotheses and explore unexplained physical phenomena in the harsh space environment. Calvin Leung, an astronomer at the University of California, Berkeley, has spent considerable time analyzing data from a new radio telescope that became operational last summer. His primary goal is to determine the origin of fast radio bursts, also known as FRBs. These are extremely powerful pulses of energy that last only a few thousandths of a second but can be emitted from places billions of light years away from us. FGBs are often theorized to originate from magnetars, neutron stars with extremely powerful magnetic fields and rapid rotation rates, which form after massive young stars undergo collapse. However, the latest figures have come as a real shock. Li Yung's research team discovered that the explosion FGB 2024-0209A originated from the outskirts of an ancient, dormant galaxy. That is, according to current theory, it no longer contains young stars capable of producing FGB. This galaxy, located 2 billion light-years from Earth, is 11.3 billion years old and has a mass approximately 100 billion times that of the Sun. This is an ancient elliptical galaxy where star formation ceased long ago. Based on current understanding, if no more young stars are formed, then magnetars, which are considered the source of FGB stars, would also be unable to come into existence. However, an FGB explosion still occurred unexpectedly in this very area. When we identified the epicenter of the explosion, we were all utterly stunned. This is the first time a globular cluster, FGB, has been discovered outside of a dead galaxy. According to Viswanjisa, a PhD student at McGill University in Canada, this raises the question: how could such a high-energy phenomenon occur in a place that has nearly ceased its star formation process? To determine the origin of the explosion, the research team used an extremely powerful network of radio telescopes. Among them is the Canadian Hydrogen Intensity Mapping Experiment, abbreviated as CHIME. By combining data from multiple telescopes, Leung and Saw pinpointed the location of the explosion with extreme precision, nearly equivalent to the width of a human hair. In addition, a new network of radio telescopes has also been put into operation at the Hat Creek Observatory in Northern California, with the aim of assisting in locating fast radio bursts, FRBs. When combined with 3 other companion telescopes, this system will pinpoint the origin of at least one fast radio burst, FRB, per day. This is of significant importance, as it helps to gather more data about that mysterious phenomenon. Leung stated that thanks to the support of new telescopes, we can trace the origins of fast radio bursts, FRBs, with unprecedented precision. Previously, only a handful of fast radio bursts, FRBs, had their origins clearly identified, but we are now able to do this routinely. The detection of an FRB in a dead galaxy raises many questions about the true origin of these bursts. If it wasn't caused by magneta, then what generated the FRB 2024-0209A signal? A new hypothesis proposes that the explosion may have originated from a globular cluster, a dense concentration of ancient stars typically located on the outskirts of a galaxy. However, this hypothesis is not yet entirely convincing, as an FRB previously identified as originating from a globular cluster actually belonged to a galaxy that is still undergoing star formation, rather than from a long dormant elliptical galaxy. This suggests there may be another mechanism, beyond the explanatory power of current science, governing the formation of fast radio bursts, FRBs. FRBs have become one of the most captivating research topics in astrophysics over the past decade. Since the first fast radio burst, FRB, was detected in 2007, scientists have recorded over 5,000 similar events. However, their origin and formation mechanism remain a mystery to this day. Modern radio telescope systems, like CHIME, along with new upcoming instruments, will continue to play a vital role in detecting more FRBs and unraveling their nature. Astronomers expect to soon discover the true origin of fast radio bursts, FRBs. The FRB 2024-0209A explosion is just one of thousands of mysterious phenomena occurring in the universe. However, if humanity can find the solution to this phenomenon, it would be a significant step forward, helping us better understand the nature of the universe and the mysterious physical processes occurring in the depths of space. A binary crystal system has traveled 10 billion light-years through space to Earth and is on the verge of merging into a monster. A newly captured image from the Hubble Space Telescope reveals how a colossal and powerful cosmic monster was born 10 billion years ago. According to Life Science magazine, the two objects detected by NASA's James Webb Telescope are actually two extremely large quasars. When viewed from Earth, they appear as brilliantly luminous objects, but in reality, they are monstrous black holes. Unlike the majority of invisible and quiescent black holes, these are violently devouring matter. Under the influence of the black hole's immense gravitational pull, particles of gas and dust accelerate, reaching speeds nearly equal to that of light. The light from all matter being swallowed by a black hole does not vanish instantly. Instead, it is compressed and heated to extreme temperatures within the swirling accretion disk surrounding it. This process generates an extremely powerful source of radiation, even surpassing the total brightness of all the stars in the galaxy, making the black hole one of the brightest and most intense celestial objects in the universe. Scientists hypothesize that extremely bright stars like these are a signature of the early universe. However, it is precisely the twin nature of this new object that makes it particularly interesting. Astronomers once considered the possibility that they were merely an optical illusion. Because of the gravitational lens, it inadvertently looked through a region of space-time bent by the gravity of a massive object. But that is not the case. They are in fact a pair of twins, another discovery from the Mauna Kea Observatory. Hawaii confirms these are not just rare ice crystals, they are also in the process of preparing to merge with one another. This merger will undoubtedly result in an incredibly luminous collision of black holes. An enormous amount of energy was released, resulting in the birth of a supermassive black hole, also known as a cosmic monster. An object located 10 billion light-years from Earth. This means that light from that object must travel across 10 billion light-years of space to reach human observation.